Alright, silly people, here's the situation. We're going to be doing a trapezoidal rule integral on some velocity versus time data that is given in the online resources that's just called velocities.txt, right? Um, and so what I have here is the example code that I just copied down from the textbook of a trapezoidal rule integral, except this is with respect to a function that is defined mathematically instead of just some data that we found. So um, that's just there for inspiration. We know we're going to need to load in some data, so import numpy as np, and then I'm just going to call the data that we're going to load in vel data for velocity data. Use the load text function to load in velocities.txt. And then since it's velocity versus time, I'm just going to separate them into two columns. A time column, which is going to be just the entire first column of the data, and also a velocity column. Stop adding a space, that's really annoying. But it's equal to the entire second column of the data, so colon, comma, 1, right? So that's the first step. N is a defined quantity given by the data. It will actually just be the length of one of these lists that we got. I know that it happens to be 100, so I'm actually going to be using that a little bit, but yeah, there's 100 entries in this list, right? And so A, instead of being 0.0, will be the first element of the time list. B would be the very last element of the time list, so time index -1. H should be 1. The computer has a hard time getting it exact for some reason, but 100 minus 0 divided by 100 should be 1, so H is also 1, which is cool. S, instead of being 0.5 times f of a, there is no f, so instead we have to index the very first element of the velocity data, so it's going to be vel 0, and then this is also 0.5 times velocity, and then you index the last element of that list. You do your for loop, so it's for k in range, and then 1 to n is actually just fine for us because you don't want it to go over n or anything. And so it's s plus equals, and instead of f of a plus k times h, a is 0. We know that the first element of the time list is 0. So, and we know that h is 1. So we literally just add in vel of k, L indexed to k, right? And then after all that is said and done, we can print out the integral. We know it's going to be 1 times s, so just s, and it gives us 8.556. So that's the total amount of distance that's traveled over the time that the velocity data is gathered, right? The second part of the problem is to extend the program to make a graph of the velocity curve and the distance traveled as a function of time. So that is something that we can do pretty easily if we just import matplotlib.pyplot as plt, and then just have it at the end of that loop plot, first of all, the velocity plot, so time versus velocity. But then also, we're going to create a list of the positions, which I'm just going to call s list, which is going to be a list that only has s in it. And inside the loop, I'm going to append the current value of s to the s list. And then when we get to the part where we plot it, we just plot time versus s list, and it's going to give us some very pretty plots. The blue one, I presume, is the velocity data. It is really not to scale with the distance data, which is fine, but it is showing that the velocity actually starts off increasing but then decreases, hits a bottom value and starts increasing again, which is sort of commensurate with what the integral looks like. It travels quite a bit of distance until it reaches a point where the velocity is now negative, so it's now decreasing the amount of displacement and then increasing towards the end. So yeah, I think it's all sensible stuff here.